I have a capacitor, I have a battery, I have a resistor, right? Okay, and then they told us the capacitance of the capacitor, well, this is 2 times 10 to the 6th, we agreed, because we like the number 12. This is 6 times 10 to the negative 6th. Oh, I have a switch. I got to draw my switch in, you're right. Let's draw myself a switch. Whoops, that looks, ah! Okay, so let's try this again. One little, one big, one little, and then I just switch like that. Okay. So if I close the switch, what happens? Goes going through the current comes out of the battery, goes, what's the capacitor doing initially? Yes, but initially it's doing what? How much effect does this capacitor have in the system? None. So what's going to happen to my current as time goes on as this thing starts to build up voltage? It's going to slow. That's all I need to know. Now I'm good to go. Right? That's the idea. That's the way you approach these. Peter, you know what's really great if you're a teacher? When you give problems, when you say, look, I need you to practice 2 problems so that before I go on and confuse you guys and make things worse for you guys. You got them all done? All the whole page done? You have 3 done. That's awesome.
Not 3 problems. That's the first number 3.
Okay. So could you do a couple problems before I do the top 2 problems and I start talking about inductors and you're like, oh God, what happened to me now?
That sounds good, Mr. Edges.
That's, yes. All right. 24 seconds. Okay, so current. So I'm going to go I equals I max. Since it's decreasing, I'm going to use the decreasing formula. There's e to the negative t tau. So I've got I equals the maximum is going to be at the very beginning. Wait, do I know what the battery is? Oh yeah, it's 20 volts. So this would be 20 over 2 times 10 to the negative to the 6th. E to the negative t over 12. So I equals 1 times 10 to the negative 5th. E to the negative 20, negative 2, right? So I just put that in my calculator equals. What do I get?
I equals 1.35 times
6 amps. Everybody got that for an answer? We got that for an answer? Yeah. Yeah. Good everywhere? All right, do number 4. All right, so I'm looking at number 4. I have a ferrite capacitor. I have initial charge on it. I'm discharging across the resistor. Flagged, I have no battery at all, which is interesting. I read that as 3 times 10 to the negative 3rd. Is that correct? Oh, microfarads, 10 to the 9th. That's lovely.
Yeah.
And then I've got I got 6.2 times 10 to the negative 6 coulomb sitting on it, which is fun. And then I have a 1500 ohm resistor, which is ridiculous. And then I want to know at 9 microseconds, so 9 times 10 to the negative 6, how much current is going through the resistor. So, first question I ask is the current going up or down? Karis?
Going down.
Going down. So I'm going to use I equals I max, e to the negative t over RC. So I'm going to start putting the pieces in. I need to know what the maximum, but you know the voltage here, right? So I'm going to go CB equals Q or V equals Q over C, right? 6.2 times, nope, that's wrong. 3 times, nope, that was right before.
6.2.
That was right before. So 6.2 times 10 to the negative 6 over 3 times 10 to the negative 9th gives me a number bigger than 2. 2 point what? 2.67 times 10 to the negative, nope, positive third. Really?
2066.
There you go. At 267, is that okay with everybody? They did the problem? That's voltage, right?
What?
2000? Okay,
Yeah,
what did
oh, yeah. And then divided by
6.2. It's not what I'm getting.
This one's calculated.
You get 2,000.
I'm still there. Oh, no, that is what I'm getting. I just didn't know I was getting it. That's dumb. Okay, so 2,670 or whatever, 666. All right, so that's my voltage. That's not good enough. I need current. So how do I figure out what my current is? 2666 equals, or 7
There should be a
equals
zero.
I.
This is a zero.
206.
2.06.
2.06?
Yeah.
You're right. I'm wrong. That's my bad. That's what you're trying to say over there.
Wrong.
2.07 times 10 to the third, right?
Yeah.
So that would be 2070 or something like that, divided by 1500, and I get my current maximum would be what? At the very beginning?
37.8.
7.8.
62.
What are we doing, Bernard?
I was gonna go to the bathroom.
Okay.
I was actually just gonna go.
And e to the negative, is it 9 times 10 to the negative 9? Negative 6?
Yeah. Divided by 4.5.
9 times 10 to the negative 6 divided by
4.5.
4.5 times 10 to the negative 6 as well? Yeah, because it's negative 9. Okay, so that just gives me a negative 2. E to the negative 2. Put that on my calculator, I get whatever I get.
1.86.
0.186
How is
amps. Got it?
So part A.
Nix, you got part A already?
Not quite. Oh wait.
Okay,
oh,
seriously.
Oh no, 4?
Yeah, you got to be with me.
Oh no.
Because I'm about to turn the corner and do 2 more things and be like, okay, I don't know what this is. Then you have a test where we say, I'm going to pull up the capacitor, put a resistor in there. I'm going to pull another capacitor, put it there. Just going to blow your mind. So let's not do that, okay? Be with me. Okay, then B says, what's the charge remains after 9 microseconds? Now, I have a couple of choices for this. Probably what I'm going to do, I could, by the way, reverse engineer V equals IR, right? Figure out what V is. With V, I can figure out the charge of the capacitor is. Great. Or I can do it from scratch, right? So I'm going to do that. The charge is going down, so I'm going to use the going down formula, the decreasing formula. Q equals Q max, e to the negative t over RC. So the maximum charge would be the charge at the beginning, because we said it's going down. Right? So e to the negative, and we just did this in the case, got a negative 2, so I'm just going to make a negative 2. Is that all right with you?
Yeah.
And then I get my charge is what?
Your charge is 8.391 times 10
7 coulombs. Okay, and then last but not least, it says, what is the maximum current through the resistor? I think we had to solve that like an hour ago.
So it's
1.378 or 1.38 amps. Got it? All right.